Hey everybody, this is section 4, reaction in cells. This is the last section, so I'm going to give you the study guide also maybe tonight, which is Thursday night, just so you can start working on it. So let me go. So photosynthesis and cellular respiration are two processes that allow organisms to meet their energy needs. This right here, these two things, photosynthesis and cellular respiration, we spend about a month and a half on in biology. So this is super important. These allow organisms to meet their energy needs. The sun is the primary source of energy for most plants and animals. The reason is because I eat plants, and plants are available because of the sun. So like everything we eat or do or whatever, it's all from the sun. All starts from the sun. Photosynthesis, the first one. Photosynthesis, plants chemically combine carbon dioxide and water into carbohydrates. So you take carbon dioxide, which I breathe out, and water in the air, and it turns it into, with the help of the sun energy, it turns it into carbon dioxide and carbohydrate, and oxygen. The process requires light and chlorophyll, which is a green pigment in plants. The formula was right here: 6 H2Os plus 6 carbon dioxides plus energy from the light, sun, equals or yields glucose and 6 oxygens. Okay, you have to know this formula right here. Box this, highlight this, commit it to memory. During photosynthesis, the energy from the sunlight is converted into chemical energy. So again, we take these chemicals right here and then convert it into chemical energy, which is glucose. All right. Cellular respiration is basically the opposite. Okay. So once you learn this formula right here, the forward reaction is photosynthesis. The reverse, if you had a different triangle, if this arrow could point this way, would be cellular respiration. So what happens is water and carbon dioxide, which I'm breathing out, turns into glucose and oxygen. And then on the flip side, the reverse reaction, oxygen from the plants and stuff and carbohydrates from plants and stuff turn into carbon dioxide and water. Okay, so during cellular respiration, the energy stored in the products of photosynthesis is released. So a forward reaction, photosynthesis; a reverse reaction, which is right here. Ooh, I already wrote it. Is cellular respiration. So just remember the forward reaction of photosynthesis, and just know it's the opposite. There is a figure on page. It's figure 19. It's in the section 4. I cannot remember the page. It is super important that you know that. That kind of just shows you some stuff. Carbon dioxide and water are the reactants in photosynthesis in the products of cellular respiration. And then carbohydrates and oxygen are the reactants in cellular respiration and the products of photosynthesis. It's the same formula. Forward is photosynthesis, reverse it's cellular respiration. Okay? All right, enzymes and vitamins. Enzymes and vitamins are compounds that help cells function efficiently at normal body temperature. So normally, if we want something to react faster or do something faster, we heat it up. But we can't do that with our body. Our body has to stay at our normal body temperature. We can go up a couple degrees, we can go down a couple degrees, but that's it. You get too high of a fever, there's some serious complications. So enzymes let us all those cells function at our normal body temperature. Enzymes. Without enzymes, cells could not digest food or extract energy from food. These are super important. Enzymes are proteins that act as catalyst. Remember, catalyst is something that allows it to happen for reactions in cells. Enzymes allow reactions to proceed faster at much lower temperatures than would normally happen. It happens at, in our body temperature, 37 degrees Celsius or 98.6 in Fahrenheit, when things would really, really happen faster if it was hotter. Okay? So, vitamins. These are organic compounds that organisms need to produce that need in small amounts but cannot produce. We cannot make vitamins. Okay? So, in the vitamins that dissolve in water, such as vitamin C, gets eliminated from our body and must be replenished daily, are called water soluble. That means they dissolve in water. That's why vitamin C is put in everything. You always see added vitamin C, added vitamin C. It's because we need it every single day. Every day we pee it all out, and every day we need more. Vitamins, so that's water soluble, dissolves in water, which was P. Vitamins that dissolve in fat, such as vitamin A, vitamin D, can build up over time in body tissues and are fat soluble. They dissolve in fat in our body tissues. Taking too much of these fat soluble vitamins can be harmful. That's why they say on the Flintstones vitamin thing, do not eat too many. And that's why they have child-proof caps on vitamins. Okay, that's it. All right, so look for the study guide. Bye, guys.